Let me give you a number. $150,000. That's what it cost not long ago to build a custom CRM dashboard. You know, the kind of internal tool a sales team uses to track their pipeline, manage accounts, log interactions. A straightforward piece of business software. You'd hire engineers, run development sprints for months, and somewhere around month 3, you'd write a very large check, $150,000, and hope it worked. Now, here's what that same dashboard costs today. Open an AI tool called Lovable, type out what you want in plain English, hit go, come back in 3 days. Your dashboard is live. Total cost? A few $100s in subscription fees. That's not a thought experiment. That is a documented, real-world benchmark from enterprise software research. So naturally, every business leader who hears that starts doing the math in their head, and the conclusion seems obvious. If software is now basically free to build, then all those old, slow, outdated systems the business has been dragging around for years, rip them out. Start fresh. Let AI rebuild everything from scratch. Clean, modern, instant. It's the obvious move. Except, here's the thing I want you to sit with before we go anywhere else. That same research, the same data that showed you can build a CRM in 3 days for almost nothing, also shows something that stops you cold. That cheap dashboard? Under the wrong conditions, it will end up costing your organization dramatically more than the one that took 3 months and 6 figures. Not slightly more, dramatically more. How? How does something that cost practically nothing to build become more expensive in the long run than something that cost a fortune? That's the question. And the answer changes how you think about AI, software, and where your organization's real value actually lives. Hey, welcome to Mindcast. I'm Will. This is the show for people who want to understand the ideas reshaping technology and business at a level that actually matters. Not the surface-level hype, not the breathless headlines, but the real structural shifts underneath. No engineering degree required. Curiosity is the only ticket in. Today's episode is built around a research report that I think is one of the more important things I've read this year. The title is a mouthful, The Illusion of the Zero-Cost Rewrite, Navigating Greenfield versus Brownfield Legacy Modernization in the Era of Agentic Generation. But I promise every word in that title will make sense and matter to you by the time we're done. Here is what I want you to walk away with today. AI coding tools are genuinely transformative. The speed at which software can now be built is extraordinary and real. But there is a trap inside that transformation, a financially dangerous trap that most organizations right now are walking into with complete confidence because it looks exactly like the smart move. And by the end of this episode, you'll be able to see it clearly. The central tension is this. When you look at your organization's old, creaking legacy software systems, you face a fundamental choice. Do you go Greenfield? Tear it all down, start from zero, let AI generate a shiny modern replacement, or do you go Brownfield, carefully, methodically modernize what you have, upgrading from the inside rather than demolishing and rebuilding? This isn't a debate for software architects in conference rooms. This decision, or the failure to make it consciously, carries real, measurable, sometimes catastrophic financial and operational consequences for any organization that relies on technology, which in 2025 is every organization. Let's get into it. Our first key insight is the economic fact at the heart of everything, and it is one that almost no one in the current AI frenzy is paying attention to. So let me ask you a question. What percentage of a software system's total cost over its lifetime is actually the writing of the code? Think about it. Engineers planning, designing, building, the construction phase. What fraction is that? The answer from decades of software industry data is somewhere between 25 and 35%, 1/4 to 1/3. That's all. The other 65 to 75% of what it costs to own a software system over its life is everything that comes after you first hit deploy. ongoing maintenance when things break, security patches as new vulnerabilities appear in the wild, compliance updates when regulations change, managing the integrations with every other system the software needs to talk to, and the cost of keeping specialized engineering talent on hand to sustain the whole thing. That's called total cost of ownership, TCO, and most organizations dramatically underestimate it. Now, when AI tools slash the cost of that first 25 to 35%, something genuinely remarkable happens to the initial invoice. The $150,000 dashboard becomes a few $100, but the 65 to 75%, the ownership burden, doesn't go anywhere. It is still there. And because cheap building means organizations are now constructing more software faster than ever before, that ownership burden is actually growing. Every cheap-to-build internal tool, every AI-generated dashboard, every rapid microservice, each of those still needs to be maintained, secured, patched, and governed for as long as it runs. The cost didn't vanish. It shifted from a visible upfront bill to a diffuse, compounding operational drain that is invisible until it hits you like a wall. This brings us to what the research calls the typewriter trap, and this is the concept I want you to really hold on to. When someone who isn't a software engineer, a product manager, a founder, an operations lead, picks up an AI coding tool and starts building, they quite naturally treat it like a very fast typist. You describe what you want in plain English, the AI writes it out, you get your thing. The assumption, entirely reasonably, is that the AI is handling the technical complexity, just like you'd hand a letter to a typist and expect the words to come back correctly formatted. But here's the thing. When a seasoned software engineer actually builds something, the typing is almost irrelevant. The vast majority of the cognitive work is invisible. It's thinking through system design. How will data flow securely? What happens when the system gets overwhelmed with traffic? When something fails, does the whole application crash, or does it degrade gracefully? How does this new tool connect to the 5 other systems in the organization it needs to communicate with? So when you prompt an AI to build a tracking dashboard, the AI does exactly and only that. It builds a tracking dashboard. It looks polished, it demos beautifully, but because the AI has no awareness of your data strategy, your security requirements, your integration architecture, your scaling needs, it creates what the research calls an architectural vacuum. The code is syntactically perfect. Every line follows the rules of the programming language, but structurally it is hollow. There is no plumbing. There are no load-bearing walls. Think about what that means in practice. Imagine commissioning a gorgeous new house. The finishes are beautiful, the layout is exactly what you wanted, the photos would look stunning on any real estate site, but the builders never installed proper plumbing.
And the interior walls that look like they're supporting the structure? Decorative. Nothing is actually holding anything up. The house looks incredible on move-in day, but the moment you actually try to live in it, to run the dishwasher and the shower at the same time, to put furniture in the rooms, the problems begin. And fixing them after the fact costs far more than building them correctly the first time would have. That is the architectural vacuum, and the research has a perfect name for what it creates: a high-interest technical mortgage on your engineering team's future capacity. You borrowed velocity up front by skipping the structural work. Now, every sprint, every quarter, you're paying interest in the form of engineers who aren't building new things, they're fighting fires in the walls of the house. Now, let's move to our second key insight, and this is where the research most directly challenges the dominant narrative. You have probably heard, it is everywhere right now, that AI is going to help organizations clean up their technical debt. All that messy, accumulated, overcomplicated code that slows engineering teams down, AI will sweep it away. Fresh start, clean code base, problem solved. The data says something very different, emphatically different. A firm called GitClear conducted an analysis in 2025 of 211 million lines of code across enterprise repositories. Massive sample, and the results should make anyone reaching for the Greenfield rewrite button stop and think hard. Code refactoring, the regular, essential practice of cleaning up and restructuring code to keep a system healthy, fell from 25% of all code commits in 2021 to less than 10% by 2024, cut to less than half in 3 years. Meanwhile, code churn, meaning lines of code written and then revised or deleted within just 2 weeks, jumped from 5.5% to nearly 8%. And studies examining over 8 million pull requests found that technical debt actually increases by 30 to 41% in the year after an organization broadly adopts AI coding tools. Let me say that again. Technical debt increases by 30 to 41% after AI tool adoption. The tool that was supposed to clean up the debt is, on average, at scale, making it worse. To understand why, you need a distinction the research draws that I think is genuinely illuminating. It's the difference between what the research calls local correctness and global architectural integrity. Human engineers, even when they're cutting corners, carry something essential in their heads: a mental model of the whole system. They know how the piece they're building fits into everything else. They're maintaining global correctness, a sense of the whole. AI coding agents work on a completely different basis. They optimize for the immediate prompt, the immediate context window in front of them. They're exceptional at local correctness, individual functions that are elegant and perfectly formed in isolation, but that intense local focus routinely undermines the coherence of the whole system. The same problem gets solved independently in 3 different files because each AI session didn't check what already existed. Error handling is inconsistent because different sessions handle failures differently. Unknown external software libraries get quietly imported to solve problems, expanding the security attack surface without anyone realizing it. The research even found over 170 applications built rapidly on one AI platform that had critical security misconfigurations directly exposing sensitive user data to the public internet. Every single one looked fine in a demo. And all of this follows a timeline that the research documents as so consistent it's almost clockwork. They call it the 90-day reckoning. Days 1 through 14, the demo high. Everything is extraordinary. Velocity feels surreal. Features that used to take weeks materialize in hours. Stakeholders are thrilled. The technical debt is accumulating rapidly underneath, but it's completely invisible. Nobody has yet needed to go back and change or extend anything that was built. Day 30, first signals. A developer opens a section of code to add a small feature and finds a 300-line block of logic with no documentation, no coherent naming, no explanation of its intent. Debugging starts taking longer. The team calls it a rough sprint and moves on. Day 60, the wall. It becomes undeniable. A product manager requests something that seems trivial, one new field added to a checkout form. The engineers come back 2 weeks later. To add that single field, they had to untangle state management logic scattered inconsistently across 7 different files, with no harmony between how the front end and back end treated the same data. Real users are now hitting edge cases that break the application entirely. The team is no longer building, they are firefighting. Day 90, the reckoning. Between 20 and 30% of the engineering team's total available work capacity is now consumed by addressing bugs and incidents that trace directly to that original AI build. The product roadmap has stopped moving. New features do not exist. Engineering leadership is in crisis meetings, debating whether to attempt yet another full rewrite or begin the slow, expensive process of remediating from within. 20 to 30% of your entire engineering organization, not inventing the future, paying interest on a debt they didn't know they were taking out 90 days ago. That is the true price of the zero-cost rewrite. So here is where the research lands its most interesting and unexpected argument. Because it is not enough to describe the problem. The question is, if unconstrained AI generation creates these problems, and if wholesale greenfield rewrites are so risky, what is actually the smartest use of AI in software? The answer requires flipping the dominant assumption about what AI is for. Right now, the universal frame is AI is a generation engine.
it produces new things. You give it a prompt, it builds. The more powerful it gets, the more new software we can create. That frame is almost completely ubiquitous right now, and the research argues it is missing the deeper and more strategically valuable opportunity. Martin Fowler, the chief scientist at ThoughtWorks and one of the most influential thinkers in software architecture over the past few decades, the person who literally wrote some of the foundational texts on how to improve software systems, makes a claim that deserves far wider attention. He says there is as much value, if not more value, in using AI to understand existing software as there is in using it to generate new software. Not building new things, reading, decoding, and truly comprehending what already exists. Why does that matter so much? Because every organization that has been operating for more than a decade has what the research calls black boxes, legacy systems, old software, often written in languages fewer and fewer people know today, by engineers who retired years ago, running on logic that nobody ever formally documented. These systems are frequently the most critical operational infrastructure in the entire organization. They process transactions, they enforce compliance rules, they calculate premiums or commissions or inventory levels. But to the current team, they are opaque. Nobody fully understands what they do or why they do it that way, which means nobody touches them,
which is its own enormous accumulating risk. The research introduces a concept for the solution: binary archaeology. Using AI not to generate new code, but to excavate the buried logic inside these black boxes. To decode what they actually do, translate that into human-readable language, and surface the decades of hardened business rules that were never written down, before deciding what to do with any of it. The Brownfield approach, modernizing carefully from within rather than tearing down and rebuilding, gets captured perfectly in an analogy from the research. Brownfield is like renovating a large commercial building while the people who work there are still inside. You're upgrading the infrastructure, the electrical, the HVAC, the elevators, but the business keeps running. The accounts team is still at their desks, the customer service team is still taking calls. Nobody loses continuity, and you preserve everything the building contains. Greenfield is demolishing the building. Fresh new structure, modern bones, everything optimized. But in the demolition, you lost everything the building contained, every adaptation made over the years, every configuration that turned out to be essential, every piece of knowledge embedded in how the space had evolved. And to be clear about how real this challenge is at the enterprise scale, Deloitte research found that nearly 60% of enterprise AI leaders, the people responsible for deploying AI across large organizations, identified integration with legacy systems as their single most difficult obstacle. Not model quality, not data availability, not budget. Legacy integration. Number one, by far. The broader implication here is one I find genuinely exciting. The AI revolution in software is not fundamentally about speed of creation. It is about knowledge recovery. The institutional memory locked inside your organization's old, messy, undocumented legacy systems may be the most strategically valuable intellectual property you own.
And the most important use of AI in your organization might not be building the next new thing. It might be finally understanding the critical systems you already have.
All right, let's pull this together and get practical. Because everything we've covered points toward a concrete counterstrategy, a better way to think about AI-assisted software modernization. The research calls it spec-driven brownfield modernization, and once you understand it, the logic is almost obvious in retrospect. The core principle is this: before AI generates a single line of new code, you must first complete two prerequisite steps. You must fully understand what the existing system actually does, and you must establish strict, non-negotiable rules governing how the new system will be built. Only once both of those things exist do you allow AI to begin writing, and even then in small, controlled, testable increments that can be validated against the spec. 3 steps. Step 1. Business rule extraction. Instead of prompting AI to rewrite this old system, you deploy AI first as a reader and documentarian. Its only job is to crawl the legacy codebase and produce a comprehensive record of everything the system does, every workflow, every validation, every edge case, every piece of logic, no matter how buried or obscure. This is where the hidden institutional knowledge gets surfaced, often for the very first time. Here's a concrete example from the research. A legacy insurance system might contain pricing logic that works like this. Start with the base premium by policy type, then conditionally apply a discount based on the length of the customer's name, then compound a location-based surcharge that's case-sensitive. That exact sequence in that exact order is what produces correct quotes. Nobody wrote it down, it just lived in the code. Demolish the system without first extracting that logic, and it disappears. Your new AI-generated system starts producing wrong quotes, and nobody knows why for months. Business rule extraction prevents that catastrophe.
Step 2. The architectural constitution. Once you know what the system does, you write the rulebook for how the new system must be built before any code generation starts. Think of it as giving the AI a building code, the same way city governments give contractors a building code before construction begins. The Constitution specifies the technology stack, the security standards, the testing minimums, the error handling approach, the directory structure. It is a strict set of constraints that close the architectural vacuum before it can form. The AI cannot choose its own libraries. It cannot invent its own failure handling strategy. It cannot bypass the tests. The Constitution governs everything. Step 3. AI-assisted code generation, but now on top of a complete specification and inside a rigid architectural framework. The modernization proceeds in small, validated, testable steps. Each piece of new code is checked against the spec and validated against the Constitution before moving on. This is slower on day one than vibe coding, significantly, but it is fundamentally more sustainable, more secure, and dramatically cheaper to own across any meaningful time horizon because you never accumulate the debt that causes the 90-day reckoning. 3 concrete takeaways, things you can actually act on, whatever your role. Takeaway 1. Cheap to build does not mean cheap to own. Before greenlighting any AI-assisted software project, an internal tool, a customer-facing product, a legacy system rewrite, demand a total cost of ownership projection, not just the build cost. What does maintaining this thing cost over 3 years? Who owns security? Who patches vulnerabilities? Who updates it when compliance requirements change? That's where the real number lives, and right now, almost nobody is asking for it.
Takeaway 2. AI needs guardrails, not just prompts. If your organization is shipping AI-generated code to production without a spec, without an architectural constitution, without a disciplined human review process, you are writing a technical mortgage that will come due. Whether you are a product manager, a founder, an engineer, or an executive, before the generation begins, insist on the specification. The guardrails aren't bureaucratic overhead. They are what makes AI-generated software actually sustainable. Takeaway 3. Your old system knows more than you think. Before approving a full rewrite of any legacy system, invest in understanding what it actually does. Use AI to read it, document it, and bring its logic into the light. That messy, undocumented, everybody-hates-it legacy code may contain 15 years of tested, refined, battle-hardened business knowledge that cannot be recreated once it's gone. It is intellectual property. Treat it that way.
All right, let me land this where we started, with that number, $150,000. And a paradox. How can the thing that cost almost nothing to build end up more expensive than the thing that cost a fortune? Now you have the full answer, because building was never the expensive part. Owning is. Maintaining, securing, governing, extending. That's where 65 to 75% of the real cost lives. And AI, used without discipline and without architecture, doesn't change that equation. It makes it worse. It gives you more code, faster, with less structural integrity, generating a form of technical debt that accelerates and mutates until one day, 90 days in, a quarter of your engineering team is no longer building your future, they're cleaning up the mess from your free build. The zero-cost rewrite is an illusion. And I think that's actually an optimistic message,
because it points towards something genuinely exciting. The organizations that win with AI and software won't be the ones who moved the fastest with the least constraint. They'll be the ones who used AI's comprehension capabilities to finally understand their legacy systems, who paired generation speed with architectural discipline, and who recognized that the real power isn't just in what AI can create, it's in what AI can illuminate. That is the paradigm shift worth paying attention to right now. If today's episode made you see something differently, I really do want to hear about it. Subscribe to Mindcast wherever you listen to podcasts, and if you have 60 seconds to leave a review, it makes a real difference to the show's reach, and I read every single one. One quick note on the research we discussed. The full report isn't publicly available, but if you want to dig deeper or connect with the people behind it, head to the show notes. There's a contact form there, and we'll do our best to point you toward the right resources. Next week on Mindcast, we're asking the question that follows naturally from everything we discussed today. In a world where AI writes code, what actually happens to the software engineer? Is the role shrinking, or is it transforming into something more powerful and more strategically important than ever?
I have a strong feeling the answer is going to reframe how you think about human expertise in the AI age. Don't miss it. I'm Will. Thanks for being here. Stay curious out there.